Professor V. Muralidhar is serving as head, Department of Mathematics, Mohammed Satak College of Arts and Science, Chennai. He has 23 years of teaching experience. He has attended 3 international and 5 national conferences. He was a resource person at the Mohammed Satak Teachers Training College in Chennai in 2012, where he spoke on History of Mathematical Genius Ramanujan. He was elected Academic Counselor, University of Madras during 2003-06. He has attended the Orientation and Refresher courses at the Academic Staff College, University of Madras. He specializes in stochastic modeling and has rich experience in discrete mathematics, operations research, statistical methods, and numerical analysis.
Welcome to UGC lecture series. In the last class, we have seen different types of data, that is primary data, secondary data, and then we have seen different examples under each head, and then we have seen different types of diagrammatic representation of statistical data, in which we have seen histograms, frequency polygons, and then Ogee curves. We say cumulative, less than Ogee curve and more than Ogee curves, and then we have seen pie charts, and then we have seen different types of charts, bar charts, multiple bar chart, component bar chart, and different examples under each head. Then we have seen how to construct a pie diagram with the help of statistical data, and then we have seen what is the meaning of tabulation, different types of tabulation, when you are given a data how to form a table and what are the different parts of a table, and then we have seen some of the examples of tables like for a simple table and a complex table with the different subheads, footnote, and different properties. Then we have seen what is the meaning of pictograms, cartograms, and we have seen some of the examples which exhibits the statistical data. So, today in this lecture series we start with measures of location. So, when I say measures of location, it means we will be measuring overall of a data. So, it represents the entire group, and there are different types of measures of location, and here we are going to see different types. The first one being the mean, where we call it as average or simple average, and we also call it as arithmetic mean, then geometric mean and harmonic mean. And then we have another measure of central tendency, that is median, and the last one we are going to see the measures of tendency, that is mode of the given data. So, whenever you are given a data, how you calculate the average? Average under different types of data, it varies with respect to the contents. For example, if you start with a discrete data, your mean is defined as average value, which is an important measure of central tendency. So, for if you take the values, discrete set of values x1, x2, x3, etc., xn, then we can determine the mean by using two different models. First one is called direct method, second one is called shortcut or deviation method. So, in the case of direct method, we calculate arithmetic mean by adding all the values divided by the number of values, which we term it as simple average. Second one, if we take a deviation method, if the values of x are very big, then we take any one middle value, which we call it as assumed value, we represent it by a. Subtract this a value from each of the given x value. In this case, your mean is defined as a plus sigma di, where I varies from 1 to n divided by n. Here n denotes the number of values, and correspondingly di denotes the deviation for each of the xi given values. For example, you can see the following problem, where we have to determine the arithmetic mean of a simple discrete data consisting of the values 2, 4, 6, 8, 10. So, here your arithmetic mean is defined as sigma xi, where I varies from 1 to 5, because we have 5 values divided by the total number of values, that is 5. So, if you add all these values and divided by 5, we get 30 by 5, hence your required arithmetic mean is 6. Second example, find the arithmetic mean for the following discrete data where you have big values like 10, 20, 30, 40, 50. So, in such a case you can use the deviation method where I take the assumed value to be 30, and if you subtract 30 from each of the given x value, we get separated D column where we have the values minus 20, minus 10, 0, 10, 20, and the total is going to be 0. And now the arithmetic mean you can determine by using the deviation formula, that is a plus sigma di by 5, where I varies from 1 to 5, and here since sigma di is 0, we have got the corresponding mean to be 30 plus 0, that is 30. Hence the arithmetic mean is 30. Now you are given some of the simple exercise problems where you have to calculate the arithmetic mean as we have given above, and the answer is also given. For the first problem you are given 5 values 30, 50, 70, 90 and 60. You can determine the arithmetic mean by adding all the values divided by the number of values, that is 5. Hence the answer you should get 60. Similarly, the second one you have to determine the arithmetic mean for the following data where we have to use deviation method and get the solution as 200. Then we move to the next type of data, that is frequency distribution. Here first we will see simple frequency distribution. Here you are given a discrete set of values x1, x2, etc., xn, where this corresponds to continuous data with the corresponding frequencies f1, f2, f3, etc., fn. Then your arithmetic mean is given by the following formulae: am is equal to sigma fi into xi divided by capital N. Here your I varies from 1 to n, and your capital N denotes the summation of the all the frequencies, that is sigma fi, where I varies from 1 to n. In the first case we have seen simple method, and the second one we have shortcut or deviation method for this frequency distribution. Here for the given values of the data, you take the middle value, call it as assumed mean a, subtract from all the values of x, we call them as di. So di is defined as xi minus a, and here the arithmetic mean is given by capital A plus sigma fi di divided by capital N, and capital N as before denotes the total frequency. For example, you consider the following problem where we have to determine the mean of the statistical data, which is a simple frequency distribution, and here you are given the number of matches, and for each of the number of matches you are given the number of goals, which is going to be the corresponding frequency. In this case, how you determine the arithmetic mean, and here your arithmetic mean we have to use the formula of simple frequency distribution, that is sigma fi xi by capital N, where I varies from 1 to n. And now you first you need to construct a calculation table where we need 3 columns. First column denotes x values, second column denotes frequency, and third column denotes the product of first and second column, that is x into f. And if you multiply each of the x value with the corresponding frequency, we get the third column where we have 8, 24, 0, 15, 42 and 80, and you take the summation, it is going to be 169, and the total frequency is sigma f, which is going to be 30, and arithmetic mean is given by sigma fi xi by capital N, that is 169 by 30. Hence the required arithmetic mean is 5.633. Now let us move to the next example where we have word problem, and here also you are given the value with the corresponding frequency, and a factory has 4 sections, the number of workers in the different sections being 50, 100, 60 and 150. The average wages per worker are rupees 100, rupees 120, rupees 130 and rupees 110 respectively, and calculate the average wages for all the workers together. Since we are given 4 workers for 4 sections with the corresponding averages for each worker, you can determine the arithmetic mean by using your direct formula of simple frequency distribution. And here first you have to construct the table where we have 3 columns. First column denotes wages, which we represent by x, second column denotes the number of workers, which we represent by the frequency small f, and third column denotes the product of x into f, and if we take the summation of x into f, we get 41,300. Hence, the required arithmetic mean is given by sigma fi xi divided by capital N, that is 41,300 divided by 360. Hence, we have the arithmetic mean to be 10,222. Now, third example, here you are given the frequency continuous frequency distribution belongs to the third type. You are given class interval with the corresponding frequency. So, you have two rows, and for this first row denotes the class interval, where you have continuous class interval 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, and correspondingly the frequency is given to be 10, 20, 30, 40, 50 and again 50. For this frequency distribution, how you are going to determine the arithmetic mean? Let us see the following table, and here in this table you have to construct a class interval, corresponding mid values you have to take to determine the x values, and then frequency which is given in the problem, and finally you have to form the product of your mid values with the corresponding frequencies, which will give you x into f column. And here for each of the class interval, to determine the mid values, you add the lower limit plus upper limit and divide by 2. For example, in the first class interval, the mid value will be 0 plus 10 by 2, that is going to be 10 by 2, which is 5. In the second class interval, 10 plus 20 by 2, so we get 15, and third class interval 20 to 30, your mid value will be 25. Similarly, you have got mid values for the other intervals to be 35, 45 and 55. Then you determine sigma f into x, which is going to be 7500, and the total frequency comes around 200, and with the help of this, now you can compute the arithmetic mean, where arithmetic mean is given by sigma fi xi divided by capital N, and here it is going to be 7500 by 200. Hence, the required arithmetic mean is 37.5. Then we give some of simple exercise problems for your calculations. The first problem is calculate the mean for the following distribution, where you are given the class interval with the frequency, and if you calculate as before, your solution should be 25.404. Now, let us move to some of the simple properties of arithmetic mean, and first of all, the arithmetic mean algebraic sum of the deviation of set of values from their arithmetic mean is always 0. If you take the all the deviations of your each of the x value, you subtract the corresponding arithmetic mean and take their summation, definitely the algebraic sum of these deviations will be 0. That is the first property. For any frequency distribution or discrete data, this summation will be 0. Second one, sum of the squares of deviations of set of values is minimum when taken about mean. This is nothing but your variance of the data, that we call it as expectation of sum of all the deviations from each of the x value. You have to subtract the mean x bar, then you are going to get the sum of the squares to be the minimum value of the given data. Third one is composite series. See, whenever you are given each of the values x1, x2, etc., xn with the corresponding weights, we call it as weights or frequencies, that we denote here by n1, n2, etc., nk. Then your corresponding composite arithmetic mean will be n1 x1 bar plus n2 x2 bar plus etc. plus n1 nk xk bar divided by n1 plus n2 plus etc. nk. This will give you the mean of any composite series. Now, we will see a simple example. In this example, the average salary of male employees in a firm was rupees 5200 and that of the females was rupees 4200. The mean salary of all the employees put together was rupees 5000. The problem is to determine the percentage of male and female employees. So, to determine the percentage of each of the male and female employees, you have to compute the combined mean of the given data. Here n1 denotes the number of male employees, you take n2 to be the number of female employees, and x1 bar denote the mean of the first set of values. And similarly, if you determine the composite mean, you are going to get the corresponding percentage to be, for male employees it is going to be 80%, female employees it is going to be 20%. Now we have some of the simple exercise problems. Suppose a train moves 5 hours at a speed of 40 kilometers per hour, then 3 hours at a speed of 45 kilometers per hour, and the next 5 hours at a speed of 60 kilometers per hour, then you calculate the average speed. So this is a model of your composite arithmetic mean. So using the composite arithmetic mean formula, one can calculate your average speed, where the solution is given to be 48.5. you can determine and check with the corresponding solutions. Now let us move to the merits and demerits of your arithmetic mean. What are the different merits and demerits you have? First, the merits. See, whenever you take averages, your merit is defined rigidly. So it will represent the entire group of the given data. Second one is easy to understand the mean and also easy to calculate, because you are going to just add all the values divided by number of values, which will be a simple computation. Third one, your mean is based on all the observations. You cannot avoid 2 or 3 values and determine the mean, then definitely you have variation. Fourth one, of all the averages, your arithmetic mean is affected least by fluctuations of sampling. So whenever you got fluctuations in your values like 1 or 2 simple values, if you got variation, the mean will not get affected. So the affected will be very least. And fifth one, the arithmetic mean is an ideal average, since it satisfies all the requisite properties of a simple average. Then what are the demerits of your arithmetic mean? See, it cannot be determined by inspection, nor it can be located graphically. Normally when you get a very big data, okay, by seeing the data you cannot determine the mean. So that is one of the disadvantages of your arithmetic mean. And second one, it cannot be used if we are dealing with qualitative characteristics which cannot be measured quantitatively, like intelligence, honesty, beauty, etc. All these things are called a non measurable quantity, where you cannot find out your mean by using your simple average method. Third one, arithmetic mean is affected very much by extreme values. Suddenly when you got any 1 or 2 values in the lower level or upper level, then definitely you got variations in the arithmetic mean. Fourth one, arithmetic mean cannot be calculated if the extreme class is open interval. Suppose you have some data where you have below 10, some you have 20, 30, 40, suddenly you got above 90, then I cannot find out arithmetic mean for such data. And fifth one, it is extremely asymmetrical distribution. Whenever I say symmetric distribution, your data is divided equally, but when I say skewed distribution, then it is not symmetric. So average is a asymmetrical distribution. And some of the exercise problem, find the arithmetic mean for the following data, where you are given class interval with frequency, your answer is going to be 26.35, which you can check it. Then we have another type of problem on arithmetic mean, where we determine missing frequency for the given data. See, in this type of problems, arithmetic mean will be given and 1 or 2 unknowns either in x value or frequency will be given, which you have to determine by using the principle of arithmetic mean. And if you see the following problem, find the missing frequency from the following data. So you are given marks in class intervals and the corresponding frequencies, where fourth frequency is unknown frequency, and arithmetic mean is given to be 34 for the given data. You take the missing frequency to be x, and then your calculation everything is as we have done in the simple average method. So you construct a table where you have got 4 columns. First column denotes the class interval of your marks, second column indicates frequency, third column indicates the mid values, and fourth column indicates the product of frequency with mid values. And once you calculate this sigma f into m, then you are going to get 2200 plus 35 into x, because in the fourth row if you multiply 35 with x, your answer is going to be a variable, it is not a number. So if you take summation of sigma fm, you have 2200 plus 35x. Similarly, in the total frequency also you are going to get 70 plus x. If I substitute this in the formula directly, you are going to get 2200 plus 35x divided by 70 plus x equal to 34, and if you cross multiply and simplify, your x value is going to be 180. So, that is the required missing frequency. And exercise, you can try the following problem. Find the missing frequency for the following data, where your mean of the data is given to be 28, and as before you are given the class interval 0 to 10, 10 to 20, etc. up to 50 to 60. Correspondingly, the frequency is 12, 18, 27 dash. So, the frequency corresponding to 30, 40 is unknown. So, which you have to determine, and then you have 17 and 16, and if you do as before, your arithmetic mean is going to be, your missing frequency is going to be 20. Now, let us move to the another important measure of central tendency, that is geometric mean. See, whenever you take geometric mean for the given data, discrete data, your geometric mean is defined as nth root of product of n values. Suppose you take discrete values to be x1, x2, etc. xn, then your geometric mean is determined as nth root of x1 into x2 into etc. xn. This means x1 into x2 into etc. xn whole power 1 by n, that is the meaning of nth root. Similarly, if you are given value with the frequencies f1, f2, etc. fn, your geometric mean is going to be capital nth root of your x1 power f1 into x2 power f2 etc. xn power fn, where your capital N denotes the sum of the frequencies. Practically, in all the problems we use following formulae. For discrete data values, your geometric mean is anti-log of sigma log x divided by n. So, first for each of the x value, you have to determine the log x value, take their summation, substitute in the formula, divide by number of values, that will give you the your answer, and if you take anti-log to that answer, that is going to give you the geometric mean for the given discrete data. And when you are given value with the frequency, your geometric mean is anti-log of sigma fi log xi divided by capital N, where we multiply each of the frequency with the corresponding logarithm of the given xi values and take their summation. And if you substitute in this, one can determine the geometric mean for a simple discrete data as well as for a simple frequency distribution. And what are the different properties you got with respect to geometric mean? First of all, the product of values of the series will remain unchanged when the value of geometric mean is substituted for each of the individual value. Suppose you are given some 3 values, say 2, 4 and 8, then your answer is going to be, your geometric mean of these 3 values will be cube root of 2 into 4 into 8. The answer is 4, because you get 4 power 4, 2 power 4 of 1 by 4. So, the answer is going to be 4. For each of this 2, 4, 8, you substitute the geometric mean 4. So, the product of these values and product of your geometric mean will give you the same answer, that is 64. Then the sum of the deviations of logarithms of original observations above or below of the data, the logarithm of the geometric mean must be equal. So, both whether it is above or below, your geometric mean is going to be equal, and then we will see the problem based on geometric mean. Find the geometric mean of the following simple data, and here the values are 40, 36, 70, 85, 15, 75, 500, 8, 45 and 250. And here, since it is a discrete data, your geometric mean is given by anti-log of sigma log x by n. So, here we got 2 columns, where first column denote x value, second column denotes logarithm of the corresponding x values, and if we take the summation of logarithm, we get 17.6373. Hence, your geometric mean is given by anti-log of sigma log x by n, and here sigma log x is 16.6373, and your anti-log of 17.6373 divided by 10, you are going to get 58.03. So, the required geometric mean is 58.03, and you can do the exercise problems. Find the geometric mean of the given data, where you have 125, 1462, 38, 7, 0.22, 0.08, 12.75, 0.5, and if you apply the formula as given above for the discrete data, one can determine the geometric mean, where your answer is going to be 6.952. Similarly, you can also find geometric mean for the following data 2, 4, 8, where you can determine by using your simple discrete data. Now, we will have to calculate the problem based on class interval, that is continuous data. So, in this problem you have required to determine the geometric mean, where the data contains class interval with the corresponding frequencies. When you take a class interval, it is 4 to 8, 8 to 12, 12 to 16, etc., 36 to 40. Corresponding frequencies are 6, 10, 18, 30, 15, 12, 10, 6 and 2. So, for this data you can determine the geometric mean by using the formula as given in the continuous series. Now, in this problem if you see, you need to have 5 columns, where first column denotes the class interval of marks, second column indicates the mid values which we denote by x, third column denote frequency, and fourth column denote log of each of the mid values x. So, we determine logarithm for each of the mid values of the second columns. So, that is going to give you fourth column, then multiply third and fourth column which gives f into log x. Take their summation, it is going to be 137.19 and 1936. Now, the total frequency is 109 which we denote by capital N. Now, your geometric mean is given by anti log of sigma f into log x by capital N. Now, we determined from the above table sigma f log x to be 137.1936. So, if you substitute in the formula, you get the anti log to be 18.14. This will give you the geometric mean for a simple continuous frequency distribution. And what are the different applications of geometric mean? See, geometric mean is used to find the average percent increase in the sales, production, population or other economic or business series. And here geometric mean is considered to be the best average in the construction of index numbers. So, in the index numbers we have different applications of geometric mean. Similarly, this geometric mean is most suitable when large weights have to be given to small items and small weights are to be given to large items. So, whenever you got such fluctuations, we use geometric mean which comes under social and economic field. Then let us move to the next model, that is weighted geometric mean. So, whenever I say weighted geometric mean, for a given data of x values, you are given corresponding weights which we denote by W1, W2, etc., Wn, and weighted geometric mean is given by anti log of sigma w log x divided by sigma w, where w indicates all the discrete values of weights W1, W2, etc., Wn. Now, let us see the simple problem based on this weighted geometric mean. Find weighted geometric mean for the following data: group and index number corresponding weights. So, weights serves to be W1, W2, etc., and index number denotes your x values. Whenever you are given this data, you can determine the geometric mean by following construction of calculation table, and you are given 5 tables. First table indicates different groups like food, fuel and lighting, clothing, house and rent, education and miscellaneous data. Second one indicates index number which we denote by x value, that is 180, 260, 220, 230, 200 and 120, and third column indicates weights where we denote by 10, 46, 8, 20, 4 and 12, and the total number of weights is going to be 100 sigma w. Fourth column indicates log values of each of the given index number. Whenever you take log of 180, it is going to be 2.2553, and similarly you got all other values of logarithm of x. Then last column indicates the product of your weights with the corresponding logs. Determine the sigma w into log x, which is going to be 233.7706. Now, you can use the formula for weighted geometric mean which is given by anti log of sigma w log x divided by sigma w, and here in our calculation table above we got sigma w log x to be 233.7706 and sigma w to be 100, and if you simplify and calculate, your weighted geometric mean will be 217.6. Now, let us see what are the simple merits and limitations of geometric mean. First we will see the merits which we have already given in the last time, And limitations, first one, it is difficult to understand, difficult to compute and interpret, and has restricted applications because of difficulty in the understanding of geometric mean, and it cannot be computed when one or more items in the series is 0, and when the both are positive or both are negative, then it is very difficult to see the geometric mean. And let us summarize what we have done today. So, today we have seen measures of central tendency, where we have seen mean, which we also call it a simple average, and then we have seen different types of mean, that is arithmetic mean, geometric mean and harmonic mean, but today we have seen only say arithmetic mean and geometric mean. We have seen different how they are defined and different types of data, how to calculate arithmetic mean and geometric mean, and different formulas and how we use practically in the problems. So, if you are given any statistical data, one can simply calculate averages and corresponding geometric mean. Thank you.